Hello friend and welcome back to your favorite technical channel AVM Tech Android. Today I am available with a ninth video lecture on heat transfer by means of conduction. You can see this is a QR code for my channel and the name of my channel is AVM Tech Android. So either directly by using this name in the YouTube or by scanning this QR code you can enter into this channel. Do not forget to subscribe this channel and share this channel to the needy students. So friend, today I am available with a ninth video lecture in which we are going to discuss about heat dissipation from fin insulated at the tip. If you refer the previous cases, they are mentioned in the description box, in which we had discussed about fin which is of infinite length. Now this is the second case related to fin in which the fin tip is insulated. So now friend, you can see here we have to discuss about heat dissipation from the fin insulated at the tip. So here friend, you can see in this video we are going to discuss about a fin insulated at the tip. We will find out what is the temperature variation in this case and what is the heat transfer in this case. Plus we are going to solve some numerical related to this topic. So all these sketches, formulas which we can see at present, that will be discussed in next some slides. So friend, the book which I am referring is Heat Transfer by Dr. A.V. Mehta and Professor P.G. Choksi from Books India publication. This is one of the most reputed publishing house. You can purchase the same book for your ready reference also. So friend, let's start with the second case related to fin, that is heat dissipation from the fin insulated at the tip. So friend, you can see at present is T0, that is the base temperature. You can see this is a wall which is at higher temperature, and you can see the heat source is available here, and T0, that is the higher temperature at x equals to 0. And you can see when x equals to L, at L you find this tip of the fin is insulated. Also friend, you can see TA, that is nothing but the surrounding temperature or air temperature. Now it is very clear from this graph. This graph is a graph of temperature variation. This temperature variation along the length of the fin. So in this graph you can see friend, when x equals to 0 here, when x equals to 0 you find the temperature is equals to base temperature, and along the length what you will observe, the temperature is continuously dropping. At this length L, what you will observe, temperature gradient is 0. So the first boundary condition is this: when x equals to 0, temperature is T0, and the second boundary condition is when x equals to L, temperature gradient is 0. So friend, you can see here two boundary conditions are available. When x equals to 0, theta equals to theta 0, and when x equals to L, what we will observe is this temperature gradient is 0, that is temperature gradient at fin tip is 0. Now friend, in the last video also we had discussed and we had derived the most general equation, this theta, that is temperature axis, that is T minus T0, that is T minus TA, that is C1 e raised to mx plus C2 e raised to minus mx. This is derived in the previous videos. And when we apply first boundary condition, what we can see, this is the first boundary condition. When we will apply the first boundary condition, we will get here, what we will get? Theta 0, that is equals to C1 plus C2 by applying first boundary condition. Now what we have to do is, this theta, that is temperature axis, that is T minus TA, and that is equals to C1 e raised to mx plus C2 e raised to minus mx. Now for second boundary condition, we have to go for dt by dx. So what we have to do is, we have to go for dt by dx, and that is this value, m into C1 e raised to mx plus minus m into C2 e raised to minus mx, and this dt by dx, that is equals to 0. So what we have to do is, when we put that is equals to 0, what we'll get is C1 into e raised to ml plus C2 e raised to minus ml, that is equals to 0. And this is our equation number B. So we know what is first equation, this is our second equation. So now when we put the value of C2 in this equation number B, and when we will go for simplification, you can say we are putting this value, we are going for simplification. So we will get C1 e raised to ml plus e raised to minus ml, that is equals to theta 0 into e raised to minus ml. So you can say C1, that is equal to theta 0 into bracket, we can find e raised to minus ml divided by e raised to ml plus e raised to minus ml, and we know C2, that is equals to theta 0 into C1. So now two integration constant values C1 and C2 are available with us. So we can find out, this is C2 available, C1 is also available. So when we will put the value of C1 and C2 in the most general equation, what we will get is this one, that is temperature axis theta, that is equals to theta 0 into e raised to minus ml divided by e raised to ml plus e raised to minus ml into e raised to mx plus theta 0 e raised to ml divided by e raised to ml plus e raised to minus ml into e raised to minus mx. So if I want to go for dimensionless temperature variation, that is theta by theta 0, we will get, that is equals to e raised to m into L minus x plus e raised to minus m into L minus x divided by e raised to ml plus e raised to minus ml. And if we want to know what is this thing, you can see according to mathematics, it is mentioned that theta by theta 0, that is temperature axis T minus TA divided by T0 minus TA, this is equals to cos h. This h is a hyperbolic function. It is hyperbolic function. It is hyperbolic function. It is not a convection heat transfer coefficient. Mind well, this is not a convection heat transfer coefficient. This is a hyperbolic function. This is a hyperbolic function. And cos hyperbolic m into L minus x divided by, again this is a hyperbolic function, not a convection heat transfer coefficient, where m is a Fin constant, that is under root of pk divided by h, L is the length of the fin, x is any distance on the fin. So this equation which you can see, this is talking the temperature variation along the length of fin when the fin is of finite length and the tip of the fin is insulated. So this equation, I hope it is clear to you. This is talking about temperature variation along the length of the fin when the tip of the fin that is insulated. So this is what we had discussed. So now it is clear, this equation number E, T minus TA divided by T0 minus TA, that is cos hyperbolic m into L minus x divided by cos hyperbolic ml. Now this h is a hyperbolic function, either this or it is this. It is hyperbolic function, and what is its full expansion, that is shown here for both the cases. So this represents the equation for temperature distribution for a fin which is of finite length and having insulated tip. Now friend, our second task is to find out what is the heat transfer through this kind of fin. So we have to apply Fourier's law, Q that is equals to minus K dt by dx, where this dt by dx at x equals to 0 distance is shown here. Now we know this is equation of temperature variation, T minus TA that is equals to T0 minus TA into cos hyperbolic m into L minus x divided by cos hyperbolic m into L. So now friend, what we have to do, this equation is with us and we have to go for dt by dx at x equals to 0. So this exercise you can see that is shown here. What we are doing is we are going to differentiate this part by d by dx, and we try to simplify it. And again, when we will simplify it, what we have to do, we have to put x equals to 0 in this case. So this is here, we are putting x equals to 0 and we will get the answer at later stage. So here x, what we can see at later stage, you have to put x equals to 0 in that case. So now friend, what you can see is this dt by dx at x equals to 0, that is minus m into t0 minus ta into tan hyperbolic, this is hyperbolic function, into ml. So because according to maths we know that sin h upon cos h, that is tan h, that is shown here. T0 that is the base temperature, Ta that is surrounding air temperature, m that is the fin constant, L is the length of the fin. And when we will put this value of dt by dx here in this equation, what we will get is shown here. What we will get, this q fin that is shown here. So q fin that is equals to K A M T0 minus Ta tan hyperbolic m into L, and if I am putting the value of m, I will get the final answer Q, that is heat transfer through the fin of finite length, Q fin, that is under root of pH AK, under root of pH AK into T0 minus Ta into tan hyperbolic ml. So we know what is the temperature distribution and what is the heat transfer through fin which is of finite length and the tip of the fin is insulated. So friend, I hope the derivation is very much clear to you. So once the derivation is clear, we have to go for the numerical part, or you can say application part of this formula, or what we learn that application part. So you can see a steel rod with the thermal conductivity 54 watt per meter Kelvin with a cross section of equilateral triangle. Each side 5 mm is 80 mm long. It is attached to the furnace wall, which is maintained at the temperature 400 degrees Celsius. The surrounding is at 50 degrees Celsius and the surface conduction is 90 watt per meter square Kelvin. Calculate the heat dissipation. Assume the tip of the rod is insulated. So friend, here you can see what is the length of the fin that is given. Thermal conductivity of fin material is given. Cross section area is given. But here friend, you can see the dimensions are given in millimeter. So what we have to do is we have to convert all that millimeters into meter. Now it is given that the base temperature is 400, surrounding temperature is 50, surface conduction or convection heat transfer coefficient is 90 watt per meter square Kelvin. We have to calculate what is the Q value. Simple. So friend, I hope this data is clear to you, and now we have to go for solution of this problem. So first we have to draw the situation according to the data. So this T0, that is the base temperature. This is a fin that is shown here. The cross section is equilateral triangle. This A value is given 5 millimeter. This length is also given in millimeter. This surrounding air temperature is given. Base temperature is also given. We have to find out what is the Q value for this case. So it is given the fin is of finite length and tape is insulated. So the formula which we have to use is this Q, that is equals to KAM T0 minus TA tan hyperbolic ml. So now first we have to find out what is the value of fin constant. So P is the perimeter, H is the convection heat transfer coefficient, ACS, that is the cross section area, K is the thermal conductivity of fin material. So for equilateral triangle, perimeter is 3A, cross section area is half of A into root of 3 by 2A, that is root of 3 by 2 A square. So A value is given in terms of millimeter, that we have to convert into meter. And when we convert into meter and put the value, we will get the value of M, that is fin constant, that is 48.06 meter inverse. Now thermal conductivity is known to us 54, cross section area, that is root 3 by 4 into A square, then M, that is a fin constant, this value, T0 minus TA, that is the base temperature, minus surrounding air temperature, tan hyperbolic M into L, this is length. So what you can observe here is the Q value which we will get is 9.82 watt, that is heat that is transferring from the fin. So friend, I hope this is a very simple numerical. This kind of numerical may be asked in any competitive examination like UPSC, you can say IES, any technical company, any technical test of any reputed company, in your internal test or in your end semester examination. So simply what you have to do is you put the formula, find out all the values like what we did here, find out all the values, put in the final equation, and you will get the final answer. But very important thing is you should maintain the units. Now one more numerical we try to see. This is a very important thing. So the pin fin is provided to increase the heat transfer rate from the furnace wall. Which of the following arrangement will give a higher heat transfer rate? Okay, I am making full stop, sorry, comma here. Which of the following arrangement will give a higher heat transfer rate? T0, that is base temperature 230. The first case is 6 fin of 10 centimeter length, and second is 12 fin of 5 centimeter length. So we are having two cases, case number 1 and case number 2. Thermal conductivity is given 200 watt per meter Kelvin. H, that is the convection heat transfer coefficient, is given 20. Cross section area of the fin is 2 cm. Perimeter is 4 cm. Surrounding temperature is 30 degrees Celsius. So friend, here the most important thing is this area, this length is given in terms of centimeter. So we have to convert that into meter. That is a very important task. And out of these two cases, we have to select which case is, we have to select either this case or this case is giving higher heat transfer rate. We want to transfer more and more amount of heat in this case. So I hope this data is clear to you. Now we will go for solution of this problem. So friend, here you can see the heat flow through n number of fin. So in the formula we are multiplying n also. This is a very important thing. Otherwise the formula is known to us Q fin, that is equals to K into cross section area into M into T0 minus TA into tan hyperbolic ml. But important is n we have to add because we are talking about number of fins. So what is M? That is fin constant, and that value is under root of pH divided by AK. So perimeter is given, convection heat transfer coefficient is given, cross section area is given, and thermal conductivity is given. Ultimately we have to convert the length which is in centimeter or area that is in centimeter square, that we have to convert into meter and meter square respectively. So we will get fin constant value, that is 4.47 meter inverse. Now the first case is, you can say fin is of 6 in number and the perimeter that is given 0.1 meter, that is given in the data. So M into L value, that is calculated here because M value is 4.47 and length value is 0.1 meter. So for first case, the heat transfer value which we will get, that is 6 number of fin into thermal conductivity into area into M value into base temperature minus surrounding air temperature into tan hyperbolic M into L value. So we will get first answer, that is 89.99 watt. So when we will go for 6 number of fin with a length that is 0.1 meter, the amount of heat transfer or heat loss from the fin, that is equals to 89.99 means around 90 watt, 90 watt. Let us go for the second case where we will go for 12 number of fin. We will go for 12 number of fin and you can see length of fin, that is 0.05 meter. So M into L value, that is calculated, and that value is, you can see 0.2235. So now we want to know what is the Q2 value. So here 12 number of fins into area, thermal conductivity, M value, T0 minus TA, tan hyperbolic ml. So this ml value we have to put here. So for second case we will get the heat loss is 94.34 watt. So definitely we want to increase heat transfer using the fin, so we have to go for second case. So this is our answer. Instead of going with, you can say, 5 fin of 1 meter length, we have to go for 12 number of fin with 0.05 meter length. So this is our required answer. So it may possible that when you are in a job in the company as a design engineer or as a expert, you have to select out of two conditions which you will prefer and why. So in this case you have to go for calculation of all these parameters, and based on that you have to give conclusion that for case 2 heat transfer is more, so we have to go for 12 number of fins with the length that is equals to 0.05 meter. So friend, I hope this is very much clear to you how to solve the numerical for the second case of the fin. So if you like this video, in that case do not forget to subscribe this channel, share this channel and like this video. Also you can give your valuable suggestions, your comments in the comment box. This is the QR code of my channel, and again I would like to know from your side what is the comments for this video. The channel name is AVM Tech Android. Thank you. Have a nice day. Thank you.